My name is Rhet Wilson. This is presenting about the bomb calorimeter. We're going to learn what it does, what its use is, and how we can perform the experiment properly. So, a little bit of background. Our history is that in 1878, the first bomb calorimeter was created by Paul Viel, and he used to measure the heat from combustion of French explosives. We had to find a way of how much energy is in a powder, in a substance. And so today it's basically used to create calorie ratings for food. So basically, whenever you put in, like, say, sour Skittles, like we'll do in the lab, you can add oxygen into it and then set it on fire, and the heat that we gain from it, say it heats up water, you can judge the heat increase of the water, and you can do some math to find out how much energy was in the substance that you ignited. And we'll go more into detail about that in the next few slides. So, our objective is to become familiar with the physical principles, procedure, and analysis techniques associated with the oxygen bomb calorimeter. So, like I said just a minute ago, bomb calorimeter is going to measure our heat from our combustion in the oxygen bomb and analyze the combustion products. Same thing. We're going to ignite something and then measure the heat that just came off of it. So we'll determine the thermal capacitance of the calorimeter as well, determine the gross heat of combustion from the known and unknown samples, so sour Skittles and benzoic acid. We want to be safe because this is a possibly dangerous lab. You want to wear your safety glasses, closed-toed shoes, pants, and cautious when dealing with chemicals, benzoic acid. Just be cautious generally. And for the calorimeter, wear safety glasses because it's a pressurized system. Who knows if the top can pop off of it? Wash your hands afterwards after touching the benzoic acid and working with the oxygen, and precisely follow instructions as per the lab manual. So the bomb calorimeter, basically like what we said, it's going to measure the heat from the combustion of the benzoic acid and the Skittles. So on ignition of the oxygen-filled pressure bomb, we're going to submerge it in water. Heat's going to transfer from that bomb to the water, and it's going to increase the heat of that. So we're going to measure that change in temperature using the DAC software. Quick overview: first law of thermo, it's our heat gain is equal to our thermal capacitance times our delta in temperature. So, like, our known fuel is going to be burned, and the calorimeter is going to be chosen as the TD system. So, in order to find the heat gain, we do some algebra, and we'll find the total heat of combustion, and we can use that and transfer that into, say, calories, so we have a calorie rating of the substance. And in each case, ignition wire must be accounted for. Next slide. So, quick apparatus. It's going to be the bomb calorimeter is going to be submerged in our water in our vessel. We're going to ignite it and going to ignite this substance. It's going to create heat, which will then heat up the surrounding water. And we're going to measure that with the DAC software. Say the water increases 2 degrees. Well, we know by the heat capacitance of the water and by the material that we put in, how much energy it took to increase the water's temperature by 2 degrees. And so we'll be able to find out how many calories were in that given serving of Skittles. And we can compare it to this pack of Skittles and say, hey, that's about right. But in general, that's how they do, say, ratings on like a Snickers bar. It's just the same thing. I think in practice, they dehydrate it so it can explode or ignite easier. But basically, it's the same thing. You just ignite it, and it heats up the water a given amount. So that is it.